Good morning. I would like to continue our talk on Chapter 8, Composite Data Type. Yesterday, we started the session 2 on Chapter 8 on this composite data type. We are up to the array. Now today, we are going to continue from this string and then set and then pointer and then list and files. Now let's get started. String in some language, it actually just arrays of characters. So there's no difference between string or characters or arrays. But some in recent language, string have been separated from the concept of array of characters because there are some nature features on these two concepts. The data concept are totally different. Array of characters actually sometimes is more related to some unprocessed character string. And string, on the other hand, is a collection of the characters or letters used for certain meaning, for example, like message or something. But character string, like an array of characters, it has different meaning. Usually it's used as the character-based buffer or something that has no special meaning on it. But string itself has special meaning, especially for message or file or a certain line of messages. So one is cooked data, the other one is raw data. So they actually has some difference. And in some other languages, they are often special cased for strings and give them flexibility that is not available for arrays in general. Usually like polymorphism or dynamic sizing, you can increase or decrease the size of the strings. But of course, in some language like Java, it is still immutable. You cannot change the size for string, but in general, string are allowed to be grow or shrink in some language like Python. It's easier to provide these things for string than for arrays in general because string are one-dimensional and non-circular. An array usually has the concept of 2D or 3D or multiple dimension, or sometimes it's a circular buffer. So it's good actually for these two abstract data type to be separated. String as array of characters. This is in C language, and it's actually when the programming language just get started early. Actually, string is just array of characters, and especially the end of the string, actually usually \0 will be used as the separator of this string. It actually marks the end of the string. Actually, this \0 may still in use for many different languages when they are implemented on the machine. But from programmer point of view, a lot of language actually don't need you to write this \0 in. And this \0 actually is ASCII code 8-bit, 1 byte 0, all zeros, and it is used as the end of a string. And in C language, you are required to at least reserve one element, one character element for the end of the string. And a string may have index, may have this content of the characters, and may have the ages for each byte. And these are 3 ways that you can access a string in C language. And in C++ language, we have we still can use the character array, and we can also use the character pointers to access an array, and you can also treat it as a string by itself. And right here, I'm more focused on the string because this is new to C language. So here we have listed down different way of constructing a string. First, you can use a constructor, and you put in a character string, array or string in there. So actually, you create a character array of characters, and you put it in here, and you use the constructor string to construct it, or you put the pointer's name or a string's name, string's reference name, and you put in there, and then you actually use this as a constructor that will create a string and assign a reference value to this str. And similarly, you can create a pointer to an array of characters using this double quote sign, and this is called interned string, and you will be stored in the global memory area. And you can also use this p1 plus 6 as a pointer and assign to this p2. Actually, these are the ages, and you assign to p2. P2 is a pointer. And as you can see, right here, hello has 6 bytes. So actually, p1 is the beginning location, memory location for this hello string. And after you plus 6, actually, p2 is the end of the string. So right here, we actually by this way, we create 2 pointers, and then we declare one string reference as 1, and then we construct one string with hello, and one string with the first 2 letters of the hello, and it's right here. You have the string, and then you have the number, and you will create the first n element in this CS will be character string. Will be constructed to the S3 string. And here you can check the different way of constructing a string, and it all is done here. The last one is actually using 2 pointers, to mark the beginning and the end, and the ending one is not included, so that's the P2, is the end of the string, and we can use that to construct a string. So these are the way to construct a string, and the constructor are listed down over here. And string as object, that's for Java language. Java has string, and even array are considered as reference data type, and in some sense, you can consider that as object or classes. So string is a special class or special object in Java language. So since it's of object type, so the storage of the string is usually in a heap, and the data, the reference is stored either in stack, or if it is static, then it will be stored in the global static area or the master area. And the object or the body of the string is stored in the heap. So you have Java heap, and you store the string 1 cat, string 2 also pointing to here. But this S1 and S2 will, if it is actually pointing to the same interned string, will share the same location. But if you use the new string object, this will be put into the, this will actually reference to a cat string in the heap. And actually this string pool is not in the heap, it's somewhere else. It's actually, I'm sorry, this could be this could be in a heap, but in a certain permanent area for that, for these interned strings. So right here, this S1 and S2, they actually share the same address, and this object type string, it will be different ages. So if you check whether these 2 reference values are the same, they are the same. And if you check S2 and S3, they will be different because they are referenced to different memory location. And but if you use that equals to chip length, they will be the same. So okay, this is the string in Java language. And in C# it is similar. So right here we have the Java and C#, the way to declare object and string and the different data type. And right here we have the sign byte and sign byte for CLR type. And this one is C# type. That's signed byte. But in C# and CLR, they have signed byte and the unsigned byte. Unsigned byte has no prefix in front of byte. And this actually interpreted as the 8-bit characters or the ASCII code characters. And this S byte is actually with sign. These are the numbers or integers of 8-bit. So this has different. So C# has more data type compared to Java. And Java actually has no unsigned integer or short or those kind of thing. But if you need the unsigned number in Java, you just put in, you just use this character short or integer or long as the unsigned integers or characters. And in fact, the characters that stored in Java is actually using character type, and it's actually 16-bit. It's not actually the byte data. And so that need to make it clear that the string of characters, the array of characters for Java, each character is actually 16-bit. And this character can be sort of as a unsigned short compared to C# language. And in Java, actually, the reason why they use the 16-bit character is because that they support the UTF-16 or those kind of data format for internet purpose. And on the right-hand side, you can see the this BNF for string. So you can have the double quote to mark the beginning and the end of a string. And inside here, you can have escape sequence. And escape sequence, you have quote sign, backslash, slash, B, F, N. F is form fit to roll up a page. Backslash N is for new line, and backslash R is for character return. Backslash T is for tab, and backslash U with 4-digit number, that's for Unicode. And so actually this Unicode is actually 4 digits. That's why we use character in Java. And Unicode could be this Unicode characters is also actually talking about the same thing. It said that this one is for the escape sequence representation, that you represent /U for the ASCII code, for the Unicode. And this one you actually put in the character of the 16-bit. So right here are the escape sequence. And escape sequence actually is already a popular standard in string for different language, including C and Java, C#, this different language. But one language has different escape sequence that is actually in Python. Python had very different formatted sequence and escape sequence. So you have to check for Python. There are some exceptions in Python. And regular expression is used when you need to match some pattern. So some function of the string operation do accept regular expression. And let's check the I think we have enough discussion on this regular expression. Let's check the next one. So some function like this split, they will accept the escape sequence. The replace, they can accept the escape sequence. So something match certain pattern will be replaced by certain string. That is actually accepting the escape sequence. The patterns, I'm sorry, accepting the regular expression. So something like this split function also accept the regular expression of the string so that they can use it as pattern matching. So some of these, I'm not sure, maybe the index of or start with or contain may also accept the regular expression, but I'm not 100% sure today, so you have to check it. So many of these different functions for string actually support a regular expression. So regular expression is quite useful in string operations. So right here, we list down the basic, very fundamental functions or methods for strings. And these are actually, most of them are the instant methods. The next topic we would like to talk about is set. Set is an unordered collection of an arbitrary number of distinct values. So any of the members in a set is non-recurring. So we can actually have several different integer or string or a floating-point number, but it had to be non-recurring. And sets in Pascal, we have such set and order type. And actually, this one you can declare S and T as a set of the range 1 to 10, or you can use set of certain ordinal type. And you can assign such a set by listing down the members. And you can also use the bracket with the range, or you can have the if statement for the set. And Pascal's set operation equivalent, including the following: equal sign, unequal. This is actually contained by this subset or equal. This superset or equal, and this one is subset. This is superset, and this one is negation. And negation will be negating the set against the domain fields. And star for intersection, plus for unit, and minus for difference. So these are the basic set operations in Pascal, and I believe most of the language that implement set have their own operators. Set, we learned about a lot of possible implementation. Bit sets are what we usually get built into programming languages. Things like intersection, union, members, membership, etc., can be implemented efficiently with bitwise logic instructions. Some language place limits on the size of set to make it easier for the implementer. And they are, implementer. And they are real, no excuse for this. And so set right here is talking about bit set. So it not only here it's actually is set of different data type, and in some language also bit has bit sets. And actually they have also different operation on the bit sets. These are the Python set, and the Python set, you use the left braces and right braces and put something inside here. So this, the way to represent list and sets are different, and you can put down a list as the input parameter to create a set. That's also possible. So actually right here are different functions for a set or method for a set. So you can use len, length of the set, and whether X member is in S or not, and subset, superset, and then union, intersection, difference, symmetric difference, copy, update, these different function. You can check it. And set in Java is a data collection, and it has complicated set hierarchy. You have collection, and set is actually an interface that extend collection. And actually, as you can see right here, set are of generic data type. You can assign a generic parameter to this generic variable E. So it can be of different type of set, and you can assign it. And you have the sorted set, and then the three basic concrete class for set is the hash set, linked hash set, and the tree set. And the operation for the sets in Java language are the following. One thing to mention about is set in Java also implement the iterable interface. So actually you can traverse through set, and you can also convert the set into an array. And Java's set, actually, you can actually also emulating it with map. And map is has key and value. It's a mapping between key and value. But the reason why maybe you can use a map to emulate set is because you usually sometimes you have some key, and that's identical key, but actually that is somehow for you to check the membership for the Java set. But you actually want to store more complicated data, maybe a record or something. So you actually should allow the value field to put in certain record field. So actually, in that way, you don't actually when you actually search for data, the key is easier to match, and the value is very difficult to match. And so by doing this, you can actually have a better way to verify the membership and the inclusion of a certain member in the set. And also you can check whether it's existing or not existing easier if you implement it with map instead of using the set in Java directly. And also this object of this value of object type, you can actually also create some linked list or more complicated data collection as the value. So you can actually extend the table for this set. So right here is one example to use set to emulate, use map to emulate sets. Let's get started for pointers and recursive type. Basics and the reference model. Basic operators for pointer, reference, node, and recursive type. Basically, right here, I'm trying to discuss the pointers, reference, and data records, and the recursive type for this pointer and reference. And pointer and reference and the records are used to construct user-defined data structures. And it is very powerful in C language, and later in other language, they all follow this. But the recent trend is like a lot of this kind of the custom design data structure was replaced by object-oriented programming, and actually the relationship of such pointer reference model, this reference model is no longer available in some language. But in some language, it still be able to mimic the function of such reference model. So right here, I'm trying to get started from C language, and I will give some example in Java language as well. Will be showing you how to construct this type of recursive data format or recursive abstract data type using the pointer and reference and records or node. And that is how people build their custom designed abstract data type. Okay, let's get started. First, we need to know about the address and pointer. And address in C language usually is used the S sign, and pointer we use the star sign. So usually we can have a variable, say we have an integer variable equals 10, that is I is a variable. And if we put a S sign, this S sign actually with I, that would be the address. So remember, this is called S sign at AT. And of course, the name of this symbol is not at, it's actually called atmosphere. I'm sorry, it has a name for this symbol, and for or something. I forget it anyway. But S sign sometimes use the ship 2. That is another S sign. For example, like we talk about my email, ECHOU510 at gmail.com. That is another S sign. But right here we use this and sign or S sign as the address. So actually that's how actually this word is A, cursive with A. So that actually is using for address. And then we have the star. Star is, I call it body. It's a body of J is a integer type. So J is actually a pointer. Or you can call this star as a content of J is an integer. So content of J is an integer, so J is a pointer, and J got stored with the address of I, so J become a pointer. And then the body of J is a pointer, so body of J is a integer, that times 2, that is this 10 times 2, that is 20, that assigned to K. And so you actually have 3 data types. You have normal variable of integer. You have the year, that's the address. Or you can have the start year or start pointer, that is actually a pointer. When you declare it, we call it this variable itself, J is a pointer. But start sign J itself actually become a body of the pointer, that actually in this case will be the same. If this is year, this will be the same as year. That would be a integer variable. So start J become integer variable. So that is the tricky part. So you need to know about the pointer and reference. Sometimes address I, then this I will be also called as the reference of this variable I. So reference, you can directly assign the value and put reference on the left-hand side. And anyway, that is the pointer and reference. Now let's look at the node. Node, sometimes we also call it a record. It's actually a special type of record or special type of structure. Right here, we define a structure node. And this is actually a structure, and it actually is also a type. So this type structure node is a type. this type of the data actually is including two data field, one data and one next. The data field actually store with integer. The next is actually the body of next is actually a structured node type. So next is actually a pointer to structured node. So right here, we actually declare one integer and one pointer. And this integer will have 4 bytes. And next is a pointer that is also 4 bytes. So totally here, one record or one structure will have 8 bytes. So we can store data with 5, and this next as the ages of 2000. And by doing that, we actually create such a record with data of 5 and ages, this pointer of 2000. And the pointer actually would be the ages for the next object. For example, we can put 8 here. And we can also put a null at the pointer of the next. So this one actually construct a list of 2 elements and 2 nodes, and each node has some data there. But the last one actually have a null to mark this the end of the list. Now let's look at how Java can work for this type of using reference to construct a linked list. So Java can also have a node. And Java node has 2 data field. You can have the value field. Actually, this is the same with data. Say here is the data field and a pointer field, a reference field. And these two construct a record like this. And then we have a constructor. Constructor do nothing. So this one actually will have the default value of 0 and null. And actually, we can also have another constructor that accept the parameter of this value and then some reference value of the node type as the constructor. And then we have the set value, get value, set node, set next, and get next. Now, how to use it? On the right hand side, we have a program to do the experiment. First, we create a node. And then assign the node's reference value to A. And then A.set 5, you set the value 5 to the node, to the value. And then you create another B object of the node type. And then we store value A in there. And then we set next to A, for this A object, we set next to B. So this next field will be pointing to this B object. And actually, this concept is a little bit different. It actually doesn't use the pointer, it uses a reference. But in fact, in Java, this reference is used for both pointer and reference. So somehow you actually will get confused. Since it's a object and then I set it to there, but it actually form a pointing relationship. And then we actually, B, we set its next to null. So this forms such a linked list. And then we set a head reference for A with the A's reference value. So head is actually pointing to the same object as A. So head become the starting point for this linked list. And then we started to traverse through this linked list. We have the head not equals null, then we print out this head pointer, get value that will print out 5 first. And then we go to the next, then we get the value and print out. And then we actually get the next value that will be null. Then you will stop. So this is how we use a node class in Java to mimic the function that actually we build a node in C language. So from this data structure, from this abstract data type construction point of view, actually node Java can almost do whatever you can do in C language. It doesn't mean that the Java is limited to the data collection only. No, Java's this reference model can be used to mimic almost all of the function that you can achieve by C language. So any kind of custom tree or graph design, you can always use such a node or different node to create equivalent data structure for Java. Let's look at this example. Right here, we have this node. We have a test node, two program. And let's do this. Let me add that constructor in. Let me add the constructor node. And let me put actually a integer val and then node. And so our value can be set by val and then node actually our next can be set by n. So this is a way to add one constructor, but anyway, let's compile it. And on the right hand side, we have same program that we shown on the slides. So now let me run it. So this show you that it will traverse through the list and get 5 and 8. Let's go back to the slides. So Java only have the reference type, no pointer type, but actually you can use also as like pointer, but no address type A data. Use pointer to complete the whole tree graph type project. But in C language, I don't think you can actually build the same data structure with the reference or address type alone without the pointer type. So the pointer and reference in Java actually are of different concept compared to C language. Pointer and the recursive type. Pointer serve two purposes: efficient access to elaborated object as in C, and dynamic creation of linked data list, a linked data structure in conjunction with heap storage. So all of the memory allocated records will be stored in the heap, and actually with pointer, it will be easy to access to the object or records. Let's call it records, because in C actually there is no real object. And several languages restrict pointer to access scenes in the heap. And in C language, it's not. C language, the pointer can be referencing the heap, the stack, the global data area. It's all be accessible by C. Pointers are used with a value model of variable. The value model we talk about actually is the variable, reference, and the pointers. These are the reference model, value model we are talking about. Syntax of operations, content, operation pointer, operations on pointer including allocation, deallocation of object in a heap, referencing, dereferencing of pointers to access the object to which they point, and the assignment of one pointer to another pointer. So actually, you use pointer to manage the memory, and also you actually use that to access the data field or access the content of the objects, or the assignment. You make copy for the pointer value or the address value for the data. The behavior of these operations depends heavily on whether the language is functional or imperative. and on whether they employ a reference or value model for variable or names. And the value model and the reference model actually has slightly different. The value model actually we talk about here is actually in C language. You assign this number to I, that is a value. And even if you assign an address to J, that is also a value, but it's of the address type. But that's still a value. So in C language, everything in the value model. But in some language, they will use the reference model. So when you copy or talk about some variable, actually they are using reference. They are using the link or the address. You are passing address or link to certain name or variable instead of just the value. So that's two models that you need to understand about. But let me pull it back. In something like Java, the primitive data type is of value model, and the non-primitive data type is the reference model. So you actually, when you do some assignment like here, you actually pass the reference from A to head. But somehow you still can use this head to access the member field and also the data field. And that is actually will be accessing the value. So value and the reference sometimes are mixed in some language. But you need to know about what is value model and what is reference model. Value model is when we copy things or assign things, it's actually passed by value. Reference model is something that we actually copy or actually assign is by reference. So right here we have 4 C family language. Let's get first with this C language. We can declare a P, that's a pointer. Then we allocate certain size of integer, one integer type memory location, and assign it to P, and P become a pointer to integer type. So we assign 4 bytes here, and then convert that 4 bytes address value to integer pointer to P. So P become a pointer to the 4 bytes of the integer memory. So then we can scan P. So we will read in data and put it in P. For example, put 10 in there. But this 10 is not value, it's a address. So we actually pointed to a certain address of the integer there. So actually this 10 is the return value for this memory allocation. And then we print out this star P, the body of P will be in the heap. And we also print out the address of P. Address of P is this location's address. Okay, that's for C language. We basically deal with the address, reference, and pointers. And in Java or C#, both, they actually using the primitive data type in value model and the reference type in reference model. But reference type in reference model can also mimic the function of the C language, is pointers or reference in combined. And actually, these two languages are newer, so they use such mixed model. And I believe that both of them are doing it quite well. Now, let's look at the C++ language. And C++ language is something in between C and Java. So it has the constructor and deconstructor. And the constructor used to allocate the memory, deconstructor used to free the memory. But that is not seen in Java or C#. Java or C#, they have garbage collection. Once you set a reference to null, then the object associated with that memory, that reference originally will be freezed. And in C++, we actually have these constructors. And right here is another example. We have the class C boolean, and then we actually can declare several reference type, and some of this reference type with constructor, it will be able to construct a object, or you will actually maybe also use the copy constructor to construct a object. And you can also use some anonymous data structure, anonymous initial instantiation statement to assign a certain C-bool or data type to a reference. So there are many ways for C++ to create a object. And it actually more flexible than Java and C#. So it's something between C and C#, and with more operators on the pointer and reference. But the way they can do is maybe can match all the things that you can do in Java and C#. Reference model. In the ML family, they use everything in reference model. So the way we call the reference model is actually everything you assign or you do is actually a reference. So right here we declare a tree type that is with a empty reference, and the tree tuple reference, you have a node of characters, and like here you have R, and you have two child tree go down. So child tree is either empty leaf or a node containing a character and two child. So it actually is empty or a node. So it's actually empty or a node. This is empty. And or you have a node. This is a node. So actually, no matter it's empty or node, both of them are reference. So if you assign some empty to there, actually all of the empty pointing to a empty reference. It is not assigning certain value over there. And right here we have a notation to construct such a tree, and this punchy sign / is a notation serve as the purpose of surrounding code, just like double quote. So it is actually a string R. String R is this node child, and then you put in this as the left child, and this as the right child, and the left child has an X and two empty field over here. So the node X has one empty left child, one empty right child. The right child for R, we have a node Y, and node Y has two child, a node G and node W, and both node D and node W have all empty child. So this is the way that using the reference model in ML family pointers. And ML family use that to construct tree. And this is early Lisp binary tree. Lisp usually have a head of the list and the tail of the list. So this is the head of the list. So you actually use the head of the list, and then you construct, you put in AR. So in Lisp, actually you have C for construct cell, and A for atoms. And atoms actually means that you have no other link and C type actually is a construct cell. So basically, you can think about this. Lisp has some atom, or we call it in the compiler, we call it uh, terminal, and you construct is just like non-terminal. So non-terminal, you can construct longer list, and the terminal part you actually will be a terminal. So right here, this actually is the list data structure of this tree, if you notice that. So that actually is the binary tree for using Lisp to represent the tree we have there. So we actually have a head and the tail. Tail had two child tree, and we have the head that put a X in there. That actually, so beginning of the of a node, it will actually have a left child and a right child. And the left child, if you put a atom, that will become the node of character we talk about. And if not put in that a atom, you put in some node, then you become the child of child tree type. So this is the way that you use the list in Lisp to construct the same tree that you see right here. So that one is actually the same as this tree. But this is the reference model for ML language, and in Lisp is actually real linked list, and this is totally possible to use C language to implement Lisp. So pointer and the recursive type. The recursive type in OCaml, actually mutual recursive type is allowed. In a compiler, for example, it is likely that simple table record and the syntax node tree node will need to reference to each other. So you build a syntax tree that we know, and then we decorated those nodes with simple table index reference that we've seen that before when we are talking about the semantic analysis. A syntax tree node that represents a subroutine code will need to refer to the simple table record that represent the subroutine. The simple table record for each part will need to refer to the syntax tree node at the root of the subtree that represent the subroutine's code. So actually, either way, they need to refer each other. If types are declared one at a time, and if names must be declared before they can be used, then whichever mutually recursive type is declared, first will be unable to refer to the other. So actually, in the C type language, is more difficult to declare such mutual recursive. But in ML language, because it's functional programming, there is no order, so we can use OCaml syntax. Right here, we declare a subroutine info that actually has a call, and actually it has the syntax tree node, and syntax tree node is defined over here. And this and the subroutine call information, this is a separate rule, will be a subroutine with simple table recursive, and actually is the record, simple table record, and simple table record is defined over here. And you will include a subroutine of subroutine. Actually, here is the action function subroutine of the subroutine info right here, and it will actually contain a tree node. And then in the syntax tree node, we have subroutine call of the subroutine call information, and that actually will refer. So this is the action function, action routine for this tree node in the syntax, and that actually in that subroutine call information, they will refer to the simple table record as well. So it's actually one syntax tree node that will have the active routine function, and that active routine function access to the simple table, and simple table over there they also have the node linkage back to the syntax tree, something like that. Now let's look at the pointer and recursive type part 2, the value model. We talk about a reference model in both ML language and Lisp language, and basically they are just like assigning a lot of reference in different locations. And now let's look at the value model. And value model actually is the tree type that used in Ada and C are both using the value model. So both Ada and C relying on incomplete type declaration for recursive definition, because they have the incomplete version of declaration. Later they can have the body or detail definition for the node. So right here we declare a type tree, child tree, and child tree pointer is a pointer type that access to a child tree. So here we have a pointer and a child tree record. So child tree record has the implementation over here. This is what people call the incomplete type. So right here, this child tree is a record. That record has a value and 2 child. So the 2 child are pointed to the child tree. So this is the way that a node declaration by Ada. In C, node declaration is easier. We have a structure, and the structure tree self-calling back to the structured child tree. So this is called a recursive definition, but it's the same with the previous example. And allocating heap nodes in Ada, to construct a record is using new. So this is not unfamiliar to us. In C language, we use the memory allocation, or we use the memory allocation of such the tree structured type, and using the size right here, it would be 2 pointer and 1 character. That would be A plus 1 would be 9 bytes. For each of the records is 9 bytes. C double plus Java C sharp replace memory allocation with built-in type safe new. So now new is more popular way to create the records or objects. And this one is in C language, how we construct a the same tree RXYZW tree. But it's actually more cleaner. Pointer dereferencing. Pointer dereferencing actually means to find the body of a pointer. So actually the pointer dereferencing in C language we use a dash arrow sign. That means this pointer we try to find its data field. So right here, my pointer is storing a address of 2000, and we find the 2000 record, and then we access the data field val, or we use that to assign val with X. And this record is actually body of my pointer, but this will be my body star my pointer dot val will get this X. And if you don't use this body sign, you actually is using my pointer dash arrow val is called dereferencing. And in Pascal modular 3, we use the cap sign for finding its body. Implicit dereferencing in Ada. So Ada start to mix up the pointer and reference. So we actually have the T as a tree record and the point P as pointer, but you can both use the data field access dot notation. Instead of the pointer, you need to have a separate dash arrow or single dash arrow for dereferencing. So Ada actually has referencing and dereferencing using the same dot record type, dot data field type access. And if you want to access the whole record or body, you use the p.o. P.o means the p pointer pointing to a certain record, and we don't pick one data field, but we pick all and assign that to a reference variable t, and that actually is of t tree type, child tree type, and the p.o is also a child tree type, so two are compatible. And now let's look at Java's reference type pointer with implicit reference, dereferencing. So let's look at the example. So right here we have another program called print hash record. So basically we construct the same A and B, but actually when we print this head, and this head actually is a reference, or we call it pointer. So if we do this, or we can have the head.h code. When we do this, let's run it. We will get the class name node at this location. So this is actually a address. So it's a class at hashcode format. If you print any reference type, then it will print out a class name at a hash code or address. That is the pointer value for this head. But if you put a toString function in there, if we put a toString function in there, this whole thing will be converted to a string. Instead of you will not get the hash code format. So by doing this, you will print out phi and a. It will print out phi and a in the location that you should have a head. So if we mark this out, and then we print this, we will get phi a. So that's the part for Java. If you actually has it doesn't actually print the true value for this variable. You would print out the reference value for this reference, and that's the reference model it has. And if the reference has the toString function associated with the head, it actually will give you, when there is the construction, when there is a operation that will be converted to string location, it will actually automatically run the toString function. So this is a little bit complicated anyway, but that's how Java works. Java's evaluation system is not only actually just find the pointer or reference. Sometimes you also call some hidden function. In this case, it actually, so in Java, there is an implicit dereferencing and implicit function access. or measure access. For example, in two-string case. So Java's reference type and pointer type is somewhat mixed, and also sometimes even with default function being associated with it. And for pointer and recursive type, the assignment in this, the imperative feature of this does not include dereferencing a dereferencing operator. Since every object has self-evident type, assignment is performed using a small set of built-in operators. There is never any ambiguity as to what is intended. So in common list, you have set F operator, and scheme use set exclamation mark or set car. Car is the first element. Car exclamation mark or set card exclamation mark. That's the rest of the list. So right here, if we have this list originally like this, and then foo is referring to list. So we do CDR foo, it will be this. Okay, and then it's the right hand side of this pointer to the node. And the assignment of set CDR foo, set CDR foo. So you set its tail. You set this one's tail CDR, and then you set that of foo with foo, so it's actually pointing back to itself. So this one can be left alone. So it's creating one node circular list. Set the CDR of the foo with the foo itself. So this actually, when you operate it on it, actually you need to have the knowledge of the pointer and reference. Now let's look at the C pointers and reference array reference. So right here, the body of A is an integer. So A is a pointer to integer, and it is equivalent to A as the address of the starting point of an array. So A is also a pointer. A with star is also a pointer, but they actually are interpreted separately. So this A, second line A, this one will be the pointer to pointer, and this one is a pointer to an array. But when we read this, we need to be careful. This one is actually an array of pointers. So it's equivalent, but not always hold. Specifically, a declaration allocate an array if they specify the size for the first dimension. So once the array with the specification of the dimension, actually it is no longer easy to build such equivalence. So let's look at this example. Both of these are a pointer to integer, and this one doesn't mean a pointer to pointer. It actually is you need to follow the rule to read this. So it actually is a array. Body of the A array type is integer. So it actually creates an n element array, and each of the array element is a pointer. So n is an array of A, n element array of A, and that A actually is a body of that is integer. So that is actually an array of n element of pointers. So this one is a 2D array. So these three actually totally different things. If you have the number in there, this one with two undefined element size, then it will be a pointer to integer. This one is one assigned that will become an array of certain element number, and this one both been assigned that become a physical 2D array. C pointer and array reference. Compiler had to be able to tell the size of the things to which you point to. So this one is bad, but this one is okay. This one is actually, you need to group this first. So this one is body of A is a array type. So body of A is an array type, then this actually is a pointer to an array. This one is actually a pointer. But when we declare that, you need to follow this statement. C declaration rule, we write as far as you can, subject to the parentheses, then left, then out one arrow and repeat. So this rule is very important. You need to remember this. Read write as far as you can, then left, then up a level. So right here, let's read write as far as possible. Is AN is an array, is an n element array. This n element array, each of the element in the n element array's body is an integer type. So this actually creates an element array of pointer to integer. And this one, we write as fast as possible, this A and hit parentheses. So this actually body of A is a array, an element array of integer type. Body of A is an array of an array of integer type. So A is a pointer to an element array of integer. Body of A is an array of integer type. So A is a pointer to an element array of integer. This is quite hard to read, but you need to follow this rule. Read write as far as you can, then left, then out one, then out a level and repeat. Okay, this is, you have to remember this. C pointer and array reference. This one actually is easy. You can declare a integer, and this A's body is integer, so A is a pointer. B is a array of 10. A pointer to this, actually B is an array of 10 elements. So we assign B value to A, so A actually also pointing to the same 10 element array. And then A's third location assigned to A, and the A's address plus 3 integer location body assigned to A. These two are actually equivalent. And B has the same value as A, so B's third index item is actually same as A's third integer. So all these four are actually all equivalent. So this one is an array reference to integer type. It ages the calculation in the union of integer. And the third integer array element that we talk about it. And this actually is the body of a pointer with 3 integer away from the actually this is the A pointer, and then count the 3 integer away, and then find the body of it assigned to n. So many C programs use integer a pointer instead of subscript to iterate over the element of arrays. So actually this pointer and array can be used interchangeably. So you actually can read this, but basically it tells you like pointer and the arrays can be used interchangeably. And this last one for pointer, we have the stack smashing. Stack smashing means if you do not check the boundary of a array and you keep increasing a pointer, you may go out of bounds. In this case, if you actually don't look at the \n and you cannot find it, then you will go out of bounds when you iterate through with the buffer pointer. So that's called stack smashing. And stack smashing can be prevented by manually checking array boundary in C, or by configuring the array hardware to prevent the execution of instruction in the stack. Now, let's talk about dangling reference. Dangling reference, we have talked about the dangling reference and the garbage collection before, but it is very short description. Now, let's get started with this dangling reference. Problem with dangling reference pointer are due to the explicit allocation of heap object. So basically, a dangling reference is a reference that is existing but no object that it can reference to, or a pair or a pointer that is pointing to nothing, and nothing, whatever it is pointing to, have been removed. And garbage is some object or the memory allocation that actually have no reference to point to. So these are different. And explicit allocation of heap object, C plus language, only in language that had explicit allocation. Implicit allocation of elaborated object, C or C#, and this language has the implicit allocation. And in fact, you just need to assign the reference to null, and the object will be considered as not as accessible and will be allocated by the garbage collection. Two implementation mechanisms to catch dangling pointers, including tombstone and lock and key. Now let's look at the tombstone approach. Tombstone approach is in the HR material for the textbook. So you need to find the HR material in chapter 8. It's a HR material. So this figure is also in there. Basically, the tombstone approach is you actually add a pointer or intermediate memory location. So your pointer will point into this tombstone and pointing to your object, that's something in middle. And this middle name actually, if actually you did allocate the memory, and then this tombstone will be set to null. So you may have a reference pointing to it, but actually that reference is pointing to null, and the object will be reused. So that this approach, we call it tombstone. So the idea is tombstone, every heap dynamic variable include a extra cell called tombstone. The tombstone is a pointer to the heap dynamic variable. So basically you have pointer instead of pointing directly to the heap record or structure, you have a tombstone in between, and tombstone pointing to the heap dynamic variable. But once it is allocated, and we should set this tombstone to null, so set it to that. When the heap dynamic variable is allocated, the tombstone is set to null, and then you know this pointer is a dangling reference or dangling pointer. And this is costly because you need memory and time. And another way to handle it is the locks and key. Locks and key is we actually have a stem or a lock value on the dynamic variable at the heap side, and also on your pointer side you have a key number, and these two should match. If they are matched, then actually this object is alive. Okay, these two cases is, and then if you actually will allocate this memory, we set this lock value to 0, then it will become mismatched for the key and lock. And in that situation, we know that this is a dangling reference. So solution lock and key, pointer instead of only being an address also have a key and are made to be into a pair, so it's a key address pair. Heap dynamic variable also have a header containing a lock, When allocated, the key and the lock are set the same. Key equals lock. Access is granted only if the lock and key match. Otherwise, it's an error. So if your lock and key are not matching, then this memory actually is not this it actually is not available. Then your pointer is a dangling reference. Now let's talk about garbage collection. Part one of the garbage collection. What is garbage? Garbage is something that nobody refers to. So assume that we set a student SA, that's a new student object. So SA is new student object, and assign the address or reference value to SA. And then we actually create another student object and assign the value to SB, student B. And then we set the student B's reference to SA. So SA original pointing to this SA object, now pointing to SB object. Then this SA become a garbage. Now SA object become garbage. It is unreferenced object. And this is one example. Another example in C language is we call this full function, and we actually declare a pointer P, and this pointer P accept the return value from the 128 bytes allocated memory in heap, and then is pointing to that block. And then this is a variable in local variable in this function. And once we return, this P actually is popped out of the code frame. So now this block of 128 bytes become garbage. So these are two cases. One is the change of the reference. The other one is the scope of the variable, of the pointer variable disappear. Then these two cases may create the garbage. So what is garbage collection? Garbage collection is to find garbage and reclaim memory allocated to it, so you can reuse that. The heap space occupied by an unreferenced object can be recycled and made available for subsequent new object. When the total memory allocated to a Java program exceeds some threshold, that's the time we would do garbage collection. Is a running program affected by garbage collection? Yes, the program suspends during the garbage collection. So garbage collection usually is a background process to handle the cleanup your memory space and remove the fragmentation. An advantage of garbage collection eliminates the need for the programmer to deallocate memory block explicitly. Garbage collection helps to ensure program integrity. Garbage collection can also dramatically simplify program. So actually reclaim the memory, maintain the program to be integral, and then simplify the program. Three advantages. Disadvantage of garbage collection, of course, you have the overhead that will drop the performance, and it requires extra memory. So CPU time, memory, both of them needed. And then programmer has less control over the scheduling of CPU time. So if you have mission critical, sometimes the background process will come out, will slow down your program. Garbage collection, issue with garbage collection mechanism design. Many languages leave it up to programmer to design without garbage collection. This is very hard, but in the old time when people do C, C++, especially C, the garbage collection is not there. So you actually need to allocate the memory and deallocate the memory at the right time. Otherwise, your memory heap space will be occupied. So memory management at that time is a responsibility for the programmer. And some other language may arrange for automatic garbage collection. And there is one way to do garbage collection. It's called reference counting. And actually, this is not in use in modern language anymore. But let's look at how reference counting can achieve garbage collection. It does not work for circular structure, so it itself has some drawback, and work great for strings, and should also work to collect unneeded tombstones. So actually, it can also should also work to clean the tombstones. So memory as a graph. We can look at memory as a directed graph. Each block is a node in the graph, and every pointer is an edge on the graph. So actually, by the referencing in relationship, we can actually find out what block have been accessed. So starting from your root node, if there is certain reference in your code stack or in your main memory area, and it is pointing to some heap area, so this actually reference the object. And by referring by the tree, we can trace down all the block not being referenced. So locations not in heap that contain pointers into the heap are called root nodes. So these are root nodes. And it can be in the register or locations on the stack or global variable. A node or block is reachable if there is a path from root to that node. And not reachable nodes are garbage. So these red ones are garbage, will need to be cleaned. Reference counting garbage collection. The main idea is to add a reference count for every object. The field is updated when the number of reference to an object change. So originally we create object of the integer type with the value 57. So P pointing to 57 object. And then we assign P's address to Q. So Q is also pointing to the same object. So when we create a list, your reference count is 1, and then after this assignment, we increase the reference count to 2. So this is called reference counting. It will keep track of how many references are there for this object. Reference counting part 2. The update of the reference field when we have a reference assignment can be implemented as follows. So this is how we implement the reference counting. So if we have a call of this, we create a new integer for P. So P is pointing to 57. And then we have the new integer 99, that Q is pointing to it. And after that, we assign Q's value to P's value for the reference. So P moved from 57 to 99. So this 57's reference count should drop. And the reference count for Q should be increased. So right here, for this assignment, we will have to check if P's value is not equal to Q's value, then if P's value is not null, that actually before the assignment, if it is not null, then P's reference count, P's dot reference count need to be dropped. So actually this is reference. This is not pointer. So reference, you don't need the dash arrow sign. And let's assume that this is something like Java situation. Don't think about C. C need to have the dash arrow. And Java, we mix up the reference and the pointer. So this is actually a P dot the field reference count. So this one drop to 0. And then we assign Q's value to P. And then the new P, if it is not null and the Q is not null, then we increase the new P's reference count by 1, so that increase this by 2. So actually this statement over here can be implemented by this statement to keep track of the reference count. So P assigned by Q will be this will be replaced by this code. And reference count has a problem, you know. Reference counting will fail whenever the data structure contains a cycle of references and the cycle is not reachable from a global or local reference. So basically, if your pointer is not pointing to anything, and also the cycle, you have the several node, but each node pointing to the next one and form a circular structure. But there is no root from the non-heap area to reference it to here, then it's in big trouble. These cyclic structure, each node has a reference count of more than 0, so they are assumed to be alive, but in fact they are not, because they have this cyclic referencing structure. And in this case, we consider this as a problem for reference counting. So here in the textbook is another example of this cyclic reference, and after this reference value being assigned to ground or grounded, or assigned null or nil, then this become garbage, but not actually being identified by reference counting scheme. So reference counting, the advantage is conceptually simple. Garbage is easy to be identified, and it is easy to implement. Intermediate reclamation of storage. Disadvantage is reference counting does not detect garbage with cyclic references. The overhead of incrementing and decrementing reference count each time. Extra space you need to store the reference count in each object. It may increase heap fragmentation, and actually nobody is using reference count at all right now for any language. So now let's look at the mark and sweep approach. The mark and sweep approach was actually popular for a while, and in Java it used to be using the concurrent version or parallel version of the mark and sweep. But now the newer Java is using the garbage collection 1 algorithm. But let's look at this mark and sweep. The mark and sweep algorithm, it is actually a commonplace in this dialects. Complicated in language with rich type structure, but possible if language is strong typed. So these are used, this mark and sweep mechanism is used for Java, C#, Scala, and Go. So as I mentioned, it has been popular for a while, but it was replaced recent years. Complete solution impossible in language that are not strongly typed. So actually, we need the language to be strongly typed. Conservative approximation possible in almost any language. And these are portable common runtime approach. Mark and sweep algorithm, it is using the positive marking. So whichever is useful, we will mark it. And for those not marked, will be considered as garbage. So when we start to work through the heap, we mark every block to be useless. So everything is garbage in the beginning. Then we start from the pointer outside the heap that we call it root node. We start from the root node, and then collectors recursively explore all linked data structure in the program, marking every new discovered block as useful. When it encounters a block that is already marked as useful, the collector knows it has reached a block over some previous path and return without recursing. So basically, you mark and sweep algorithm is from the root, and then you do depth first searching, and then you mark every block, every of each child block as useful. But the algorithm itself is recursive. You need to start from a root node and visit all of the child nodes, and each one needs to be marked with the useful mark. And then you go down first, go depth first, and then come back to progress. And the collector again walks through the heap, moving every block that is still marked useless. So after the marking for all of the useful block, we go through the heap again, and then we actually moving of the block that had not been marked to the free list. So here is a diagram for the mark and sweep collection. This algorithm can be built on top of the memory allocation of free packages. So actually, it's one thing that can be compatible with the C's memory allocation and free package. And when out of space, we use a mark bit in the head of each block, and we actually mark starting from the root and set mark bit on each reachable block. And sweep, we just scan over the whole memory space and then find those blocks that are not marked. So initially we start with this root node, and then we go to each child, this one, we mark it. Starting from here, we mark it. So these two are used. And then this child go to this child, so here mark it. And this one also go to each child, mark it. So there are two free area. So we will find out after we done the first search. Okay, we done the depth first search, and we will mark it. So the assumption for simple implementation, for the application program, we should have the new operator that return pointer. So this will be allocated in the memory, and then we have read. So read the location I with block B. So actually we will read from that block, and we can write to the block. So these are the operations for the application program to do. You can create a memory block, and then we can write to it, and then we can read from there. Each block will have a header words. We mark as a B-1 for the block, and this one is used. And this one is used for the mark bit, used for different purpose in different collectors. Instruction used by the garbage collector, these are the function the garbage collection program will do to check a pointer, whether P is a pointer or not. If there is a pointer or a integer value, it passes. And then we return the length of the block. Certain block, we return the length of the block. And we return all of the roots, get roots. This function will be used by garbage collection algorithm. Let's look at it. So right here, if we have a mark algorithm, so we do that first traversal of the memory graph. So we pass through a root node right here. So root node pointer is right here. We check if it is a pointer. If not, we return. Then we don't need to go down. If it is, then if this block is marked, if already marked, then actually we will return. It means that this block is already been marked. And if it had not been visited, then we set the mark bit to be true, and then we go through all of the child nodes and mark the child node. So this is recursive, and actually it's recursive algorithm. It called mark itself. So you will go through all the child in the children in the block, in this block, and then recursively do this marking operation. So for the cleanup part, the sweep part, we have this root node. Actually, I'm sorry, we had the beginning of the area of the heap to be clean and the end pointer. So we start to advance P. Initially, if it is less than, so it's less than the end. Then if the bit is marked, if the mark bit is marked, then we clean the mark bit. Means that one is a valid block, but we actually clean the mark bit out. So for next time, for the marking process, we will be able to mark it. Otherwise, we will allocate a bit set P. So we actually will check if the allocate bit set, if the memory is allocated, but without mark bit, that means somebody used it, but actually it is not recycled. At that time, we actually clean that block out. And then after that, we advance this P by the size of the current piece block. And then we move this P pointer to the next block. So after this, we have already seen that the mark and the sweep algorithm is a recursive algorithm. And the problem with recursive algorithm is it actually is not scalable, and usually the time will be unmanageable. And because if recursive function can only be useful if it is tail recursive and the degree of the recursion is only one, or n log n way, so that will be manageable, checkable. If it is some algorithm like this one, it is depth first searching, then the time that need to finish this marking phrase will be huge if the number of the node is huge. So during the depth first searching, we will do pointer reversal that will help to reduce the time. So we actually just go through the path, and for example, if originally we always all pointing to the right, sorry. So if originally it all pointed to the right, and then we actually go from root and we check this node, and we will make the pointer pointing to backwards, to reverse. So we could keep doing this, and here we are here. This is the current one we are visiting. We change the direction to here, and then we move on to the next one. We will also change the next one to this direction. And if this is the end of the tree, then the whole direction will be moving back like this. Then we just go back one level just by move of the actually just by move of the pointer. You don't need to call the mark algorithm recursively. So implication objects are broken while being traversed. All computation over object must be halted during the mark phases. So right here, let's look at the textbook's example. So let's show you how the pointer reversal can help us to mark the whole block and maintain the algorithm to be linear time. Right here, we started with a root node, and if we would traverse down this right path, so we actually current node is here. We move the current node to the child, and then we actually update this original link to the child to ground, and then we actually move the previous to here, and then after that we move down to its t's child to this u, and then on this u we actually have the pointer to u pointing to t's current node's father. That is the previous, that's denoted by previous. At that time we move this to previous, and then the current node is moved down to this, and the previous set to this. So we successfully remove this part to here, and the next one we have the current node to be this, previous node set to here. So it will be setting this pointer to x to the previous. And by doing that, we actually reverse the U-link and this one down here, and then we go down, reverse this link from here to here. So we actually will finish the reversal of the pointer like this. And then we can go through, if we hit the leaf node, we will go back and then go back the path and then finish this path and go back. When we go back, whatever we come up or go back, actually it's only by the change of the record. We just change the pointer. We don't need to call the mark. So this algorithm can be done by a while loop to finish it instead of the recursive call. So that will save time. This is the way we use to save time. But we will also go through the tree by linear traversal. So this is kind of like the iterator traversal of the tree. This will convert a recursive call, recursive function into a linear function or while loop iteration. So right here we have the real world garbage collection model that's actually for modern day, the newest Java, and is using the garbage collection one algorithm. We have Java memory model. We have heap. We have method area for constant area and methods, and we have thread per thread memory. So this is the Java memory model, and then we have this heap and garbage collection area that's under this heap. And this, if we zoom out, it will be something like it. You have the Eden space, you have S0, S1 as a survival space, and then we have the tenure the space, and the permanent older tenure just for this space. This one will be this blue one, and this survival 1 and 2 are this one and this one. And they are permanent generation, that is the method area. So this is the memory model for garbage collection one algorithm, but we can click this. And then on the Oracle website, you will be able to reach this garbage one collector, GC1 garbage collector overview. Actually, it's quite detailed. So you can actually zoom out to read this if you need to know about the newest garbage collection in Java. Okay, the next thing we would like to discuss is list. A list is similar to array, but somehow it's also like a linked list. So, and list actually can be implemented by array. For example, in Java's array list, it is actually an array. It's not actually implemented by linked list. So list conceptually is a abstract data type, but in reality, the implementation can be a linked list using the pointer and reference and record or structure, or it can be implemented by array. So let's look at this conceptual or abstract data type list. A list is defined recursively as either the empty list or a pair consisting of an object. Lists are ideally suited to programming in functional or logical language. So actually in Lisp, in fact, a program is a list and can extend itself at runtime by constructing a list and executing it. List can also be used in imperative programs. So this list can be used in Python, can be used in Java, can be used in Lisp. So it's everywhere. It's just have many different implementation, as I mentioned. So the basic operation of the list in Lisp, you have the constructor, so you can actually count a member and add it into existing list B. So basically, you have the new member put to the head of the list of an existing list, and then we have the car CAR that actually will get the head element member for a list, and we can have if we car neo, then this is undefined. Undefined means some implementation is acceptable, will return neo, some will complain, some compiler will complain. That depends on the language. And then if we do card has, we would return a list that's the rest of the list except for the head or the first element in the list. So we return the rest of the list. And the card of a single union element will return null or neo. In this situation, it's neo. And we can do card neo, then that's undefined. That also depends on the compiler or interpreter. Then we can append two lists, and then you become a new list. Here we use this double arrow sign to means the evaluate to. So actually that's the value you will get. The car and the card of the empty list are defined to be nil in common list. So this one in common list is null or nil, and it scheme the result in dynamic semantic error. So basically, list operation in ML language. ML means OCaml and other SML, those different ML language. And this is actually similar to Lisp, except that the operators are different. So we use double column to construct a element into a list. So it becomes the head of the list. And then we have the head, HD will find out the head element. Head of a empty list will return long time exception. Tail of the list will return the tail list. Tail of a single element list, it will return nil. Tail of an empty list will be an exception. And two lists with S sign, this S sign is the shift to key, will give you a list like combining the two lists. Runtime exception may be caught by the program if desired. Further detail will appear in section 8.5. So ML and Lisp, both ML and Lisp provide many addition of list functions, including ones that test the list to see if it is empty, return the length of a list, return the nth element of the list, or a list consists of all but the first element. So actually, these are the car and card function for the list. So the one we just introduced are the basic operation for the list, and this list operation function or operators all available in Python language. So Python basically can complete all the list operations that is in ML and Lisp. Reverse the order of the element of the list. This is also available. Search a list for the element matching some predicate. Apply a function to every element of the list, returning the result as a list. And I believe this list operations also are available in some language like Java, which has the list interface. And in Python, we also have this list comprehension. Before we expand that, let's look at this mathematical set model. In mathematical set model, we can represent this set by exemplar. And this exemplar actually for every I that belong to this set 1 to 100, and I mod 2 is 1, that means I is odd. So any number in 1 to 100 integer that is odd will be a valid I. So we will have the order member that is I times I. So this is I squared for all the I that is an odd number between 1 and 100. So you have the 1 squared, 3 squared, 5 squared, up to 99 squared. So this is the set. That is, we call this as list comprehension, but in mathematical is a actually it is a set by exemplar. And we can have here we can have Pascal language that will write down as this: I for all of the I belong to this range, and I mark 2 equals 1. We will return I squared. Find all the example that met this condition, and we will include the members in the list by I squared. In Python, you can use it for I in range 1 to 100. And this one actually is not 100% accurate because this is the ending index. Actually, if you put 101, it should be also okay. I would think that this mathematically should match to 101, not 100. Anyway, the textbook had this, and then it is up. So this is the qualifier for the I, or we call it exemplar listing. And then we actually list down all the I square. F sharp is similar. It used the EO statement, but the qualifier is similar. So this list comprehension is available in Miranda, Haskell, Miranda, Haskell, Python, and F sharp. They provide list comprehension that resemble those ML, but with an important addition mechanism. So up to this point, I would like to talk about the advantage of Python. Python is a language that is all object-oriented programming, that's for sure. So we know that Python is on top of Python virtual machine. Python virtual machine is on C++ type of environment, but it hides all the detail by the interpreter. But Python, actually, the language-wise, it actually is a, I would say it's a strong type language, but dynamic type. So its type is defined at runtime, and that's something that will save time for engineer to write it. It will be easier. But Python, on the other hand, because it is object-oriented, it also has the nature of functional language. For example, it has all of the function available in this functional language for this list operation. It has all of that. So Python is able to replace all of the functional programming language like Lisp or Haskell, but it is also an imperative language. So Python is very suitable for machine learning or something that doing AI, those computation. And actually, it is also good for data analysis if you need a data mining and machine learning pattern for the numbers. And Python is a good language for that. The only problem with Python right now is its speed. It's not perfect, but somehow because Python has the scripting nature, so Python actually can call C language. So the combination of C language, Python, and the Django framework for database, and the NumPy, SciPy package, and ML packages, Python actually is a good combination, a good language to do a lot of things for machine learning and AI stuff. And this right here show you that Python can do whatever functional language can do. Now, let's resume our session. I would like to talk about file and the input-output. File and the input-output are spatial data format or spatial composite data type in any language. So, and usually it is very important for a program because a program consists of the processing part and also consists of the I/O part. And we talk about so many abstract data types that actually are all the processing part that actually are related to computing. But any program will have to output its data format to disk or to some devices, monitor or scanner, something like that. So you always need the I/O stream or file stream to process those I/O for a program. So right here, I would like to talk about this file and I/O streams. File and I/O stream, I/O facility allow a program to communicate with the outside world. They are iterative I/O and the buffered I/O, and buffer I/O sometimes also called as I/O with files. Interactive I/O generally implies communication with human users of physical devices. And these sensor devices, usually have sensor or have output. So it can be your fingerprint sensor. It can be your microphone for audio. It can be your camera. it can be a printer, it can be a monitor. So these are all I/O. It either outputs some data to the device or it acquire the information from that device. Files generally refer to offline storage. So actually it's not actually stay with the program, but you can access the file and the I/O device can update the storage or some disk, and you can actually fetch from there. That's another things, another way of communicating between the data and your program. So it actually implemented by the operation system. So file may be further categorized into temporary and persistent. And here, let's look at the Linux or Unix file permission. In Windows NTSF system, they have their own file descriptor or file data, but let's use Linux and Unix system as example because all of the operation systems, including DOS or Windows NTSF file system, has similar record, and Unix and Linux have been the protocol for quite a while. So let's look at this. The first data set will be the file permission word. The permission word including 10 digits that includes 3 group of the read-write executable bits and 1 file type. The file type, if it is set to be 1, that is actually a directory. Other than this file type, we have 3 access permission bytes or words, and each one has 3 bits. So this first group is user. So user, if it has a read ability, then we set R to be 1. So this is read, write, and executable. 3 bit for 1 access permission. This one for user. So for example, we have Mr. A, that is himself, to access this file. It will be its permission will be defined by this 3 bit. And if he has a Mr. B, C, D in his own group, these 4 people, actually the 3 other people in the same group will share this group access ID. So for example, in this case, the user himself, he can read and write and execute a program, but the group people actually cannot write the program. So that this makes some sense. It can only share the data, but cannot share the data for reading, but cannot write it. And execution sometimes is also related to access. So sometimes you touch it or something actually is defined by this access bit, executable bit. And the third one is other. And in this example, the other was prohibited to do anything and outside of the group. So that's actually rewrite, executable, or impossible. And then after that, you have the number of hard link is 1. And this actually, sometimes you know, in the file, you have the hard link and the symbolic link. Symbolic link is only a shortcut. So that this one is to denote the real hard link, a number of hard link. And then the owner's name, group name, and file size in terms of block using the 512 bytes block, and then modified time and the file name. This is the file information when you do ls in Linux, and ls is short for list. So they try to list your information for a certain file, and that this file permission and file description information will show up if you use the list in Linux or Unix. And here show you the file system abstraction. First, let's look at the right-hand side. We have an application program, and that accesses the I/O system. And I/O system will have a driver table or file table. And actually, your file handler is inside this I/O system, and the file system a file handler actually pointing to file system. Your file system is actually your NTSF or your Unix file system. So you have file handler that access the file system, and file system will drive the block driver, and this one actually from the file system that including the so-called file allocation table, those kind of things, and it will go through certain buffer to drive the device. And this is block-wise or file I/O, and non-block-wise per symbol or per bit devices is non-block device, and that actually can directly access the device. And this doesn't go through the file system. So this is how usually the Windows or Linux work on file or I/O. And on the left-hand side, you have a description for application, logic file system. This logic file system actually talking about the I/O subsystem and also the file system. And some part of it is the file organization module, that is translation from logical edges to physical edges. So this logical file system actually is about this I/O system for the file handler, and a real mapping of the file from that file handler table to the file system is translating from the logic to physical edges. And then after that, you have a basic file system that's between this file system and block device that actually including the access of the driver, manager of the buffer and caches. And then the lower level will be the driver for the I/O control, and it may feedback with interrupt or transfer of informations. And these are device or storage. Handling file. In C language, I will use the C language as example because it's more complete and more lower level. So you will learn more about the file structure or file system. First, let's declare a file type. Actually, in C language, you need to include a standard IO.h, and then there you have the file data structure. So this file is actually a file handler, and that is actually a record or structure, and you actually has this body size. So body of FP is a file structure. So FP is a file pointer, or I call it file handler. So this is a file handler for a file string. And this file string, when you can use file open, F open, that means file open with the file name and accessibility. This one is read only, and you open the file with read only mode and assign the file handler. This file open actually will build a file structure and return the pointer to this file pointer or file handler. And then this file pointer, you can do file scan, file print, file get, file put. These are the block operations, and you can also do it in binary mode. That's F read, F write. That's in binary mode, and actually it's byte by byte access. And then we can close the file with file close with a file handler as a parameter that will close the file. File open name is F open, and you put the name here and the accessibility here. And right here, this example, if it is null, that means that the open has some error, so you put out the error. And you can also open it for write mode or append mode. Append mode is the write mode, except that it will not append to the head, but it will append to you will not rewrite the program, the file. And append mode is following to the append some information to the end of the file. So this one is open for writing. It will start from the beginning of the file, and this one is file open for writing, and also it will be writing to the end of the file. So file open mode, we will have the R reading mode, and RB means this is mean binary. So you have file open for text mode or you can do file opening for binary mode, and you can write binary mode, append binary mode, or you can write plus. Write plus means read-write enabled. So you have the read-write enabled and the read-write enabled in binary mode, and this one is also read-write enabled in binary mode. Text file processing. For text file processing, you can have formatted input, and this format string is the same as the format string that you use in Java, and also you can have the file scan, and this one also is similar to Java, but you need to put your file IO file handler over here. These two actually similar to Java's printf. Java printf, you have system.out, that's the system output is the print that will print to a so-called console. And if you have a file handler, you put say output.printf, that will print to an output file. But that output file is an output handler. You don't need to put file handler in Java's case. But in C, you do need to put the file handler here because C is not object-oriented programming. So you need to put a file handler over here. Same thing for scanner. And this one actually is in cook format or formatted output. If you want to put in the text mode, but it actually need to unformatted format, then you actually can use this file handler to the end, and the number of the characters and the character string over here, something like that. So this one is file get, and the file put. Put is to write, and get is to read. And here is an example for delete the new line mark, the \n. So actually we declare two file opener, one for input, one for output, and the input actually is the argument 1 from your console. So here in C program, you have the argument count. That would be the number of arguments. When you type in the command line, say you have this program, say delete line, and then you have file name, file 1 name, file 2 name. So delete line F1, F2, and then F1 will pass in right here as the first argument. And argument 0 is the delete line, the command. And argument 2, F2 will put here. So argument 1, the file 1, open for reading, file 2 for writing. So actually we open two files. And if F1 is null, then we will actually print out a file not found, and we will finish the program. And if not, then every time we open the file, and then we in 100 symbols into buffer, and then if buffer is a string, is not a empty string with a change line, then we'll put a whole buffer into F2. So actually this one is just detecting whether the read-in data is a new line mark or not, and then we write everything else into the file too. So by doing that, we will connect all of the text into one sentence or one line instead of having different lines. And then at the end, we close both of the file handler. Binary file processing. For binary file, we can have fread and fwrite. And again, we need a file handler. And right here, for reading, we need to select a buffer pointer, and then the size format, say we have integer, then we should put in integer for 4. So you actually, right here, usually you are using size of function to calculate a certain data type, and then the number of the size of the symbols or of the integer or floating point. So the total size is actually, this is size times n. That's the number of bytes being write into the buffer, from the buffer to the file. I'm sorry, from the file to this buffer for reading, and for writing is opposite, is from buffer to the file. So right here we have one. This example, we open this st file for read-write purpose, and then we actually on the console, and then start to read in data. So console will print out this, and then you type in this information. You type in this information for student ID, student name, student year, number of year attend the school, and the major. And the scanf function will actually return the number of the the number of the arguments or the parameter being read in. So if it is equal 4, that means you enter the right format. So we continue to do that. So otherwise, we will actually break the loop and then finish the program. And after that, actually, you actually start to write out to file pointer. So actually, we scan in from console, and then we write to this st file. We write the size of student structure. So this is not integer. So this whole structure, and one record with print out right there, and the record is from student pointer. So student pointer actually is from here, and right in from here. So this one actually assign the ages of student to this. This actually become a reference sharing. The ages assigned to the body of this pointer. So that is actually, this one become a pointer to the structure. That's somehow you share a reference. And you write out this record to one line in the file, and continue to do that until the input format is run. So you hit Control Z to finish the input string, and then you will close this operation in this student 1 program. Student 2 program is right here. You actually open the student file for read and binary mode, and after that you actually print out the information, and then you start to read. And if you read in something, then you print that to console. So that file will be read in, and then print out on the console, or show similar to the previous console output format. So actually, eventually, this file will print out something like this. And here has another way to do random access. The previous example all are in sequential access of file, but C program also allow you to do random access. The random access means that you can actually assign the location you want to write out the data, and then or read in the data, and then you read directly from there. So you need to have the current position, and also the current position will update after you do some operation on it. So related function including fseek, fileseek. So you actually has some mode, and then you actually access with the file pointer. File pointer will point to a certain file, and the offset, that means that which byte from starting of the file that you would like to access. And then rewind is to set the file current position to the head, and the file tail is actually to set to the end, I believe. So right here for fileseek, you actually have, if you put a mode for seek set, then you will set to the starting location for the file to start from. And you have the seek current that would actually, if the file is not closed, it would search for current location, and you actually will seek for the current location for the long integer type. This L is for literal long format, and then it's 100. So it's 100 location offset starting from the beginning of your file, or you can seek for the end. So these are 3 ways to set your current position. So right here is one example. This one we open a file. That is argument 1 for appending. So we open the file for appending. And then we have a buffer of the character W with 256 bytes. Then we actually push. This one actually will be printed to your console. So you basically you read the argument 1. So basically your program name is called word append, and then you open the file message text. So actually this one will open the message text file, and then you print out these 2 messages. You print out this message, and then you start to get a word come in. If the word is not dual and it's not end of string, then we actually print out to the output file. And then after you print out all of the things from the file, we actually put file contents, and then we want your pointer to the beginning of your file. And then you actually start to write out those words to, the first one you actually is you start to write out by printing all the words you read in from message.text, and then next one you actually you want the file pointer, and then you start to read in from whatever you have write out, and then you actually print that to the screen. So what happened is that you will first write to your file with this whole thing that is from this message.text file. You write them out, and then you actually you write them with a append mode, and then actually you will read in and print it into your screen. That would be something like this. And then if you close, if no, you will say there's an error for file closing. So this is one example for the random file access, random access for the file. And so in this lecture, we actually present a whole operation, including the read, write, and append mode for files, and also we present the random access for the file. And these are the basic operation for a file. And we also explain with the C language is a file handler and buffer and different input mode for the different mode, for the text mode and for the buffered mode, block mode and non-block mode I/O. We both actually it's text mode and the non-text mode binary mode I/O using the file. Okay, let's move on. The last lecture in this chapter would be the namespace. And namespace, we mentioned about this in chapter 3, I believe. This space is a compartment, and in the namespace, you will be defining different class global variable function under one compartment. So inside this namespace, you will make sure a certain name only will be consistent, and make sure that some other module may have the same class name, but you will not bother if you use the right namespace. So namespace is a logical compartment used to avoid naming collision, and these statements I show you in chapter 3, but let's repeat again. The name conflict and the collision always occur and may occur. The same program is using more than one library with some variable or function having the same name. And then we need to use the namespace to distinguish them. And then the name collision may occur for global variable, global function classes. Default namespace is global namespace and can access global data and the function by preceding double column operator. We can create our own namespace, and anything declared within namespace has scope. limited to namespace. So once you declare a namespace, the scope will be limited to the namespace. Creating namespace, creation of namespace is similar to creation of class. So actually, you add one layer of the abstraction. Namespace declaration appear only at the global scope. Namespace declaration can be nested within another namespace. Namespace declaration don't have access specifiers such as public or private, and it's actually all public. Other people can always use some namespace. No need to keep semicolon after closing brace of definition of namespace. So there is no semicolon needed to the end. We can split the definition of namespace over several units. So the syntax of namespace is put the namespace and the name of the namespace. And they put all the member, something like global, variable, constants, and classes. And like here is one example. We can define a namespace ns1 with 2 classes. And we can also have a namespace 1 in another file, that's class 3. And in order to make sure only one is in power, you need to include the right.h file. What is unnamed namespace? Unnamed namespace is a namespace without a name, but in reality, it's not without a name. It actually has a name that is assigned by the compiler. So unnamed namespace is the other replacement for static declaration of variable. They are directly usable in the same program and are used for declaring unique identifiers. So you use the unnamed namespace to make sure that your identifier is unique. In unnamed namespace, name of the namespace is not mentioned in the declaration of namespace. The name of namespace is uniquely generated by compiler. The unnamed namespaces you have created will only be accessible within the file you created. So the unnamed namespace is to define a certain namespace used only for your own file, but that will guard against any other outside variable to make sure your file is safe. You can consider this unnamed namespace is something like a gray wall to protect you. So any outside conflict will be blocked outside. So right here, we have a demo program, NS1, and actually it's quite simple. Let's look at the example. Here is the project NS1. Let me open this Cobra file. It's quite simple. You actually include the IO string and use the namespace std. And right here, it declares a unnamed namespace with only one integer, I. So this unnamed namespace will be used in this program directly. So this I is actually this I. So let's do this. Let's click in Cobra. This one is build. Let's build the program, and then let's run. So the value is 10. The value is 10. I equals 10, and then print out the value. After that, you need to hit any key. You will return to here. Let's go back to the slides. So the next one, I won't go back to the full mode because that will waste our time. And then right here, actually, how to use namespace in C++ programming language. We can use scope resolution. So right here, we will declare in the demo 2 program, the NS2 program, we will have namespace named first and one named the second. Both of them have the variable of I, and we set the namespace i's value to be 1, and namespace second's value I to be 2. So the variable I in first namespace to be 1. The namespace I in namespace second will be 2. And then we using first namespace double column I, that's using this specific I over here. And then we will print that out. So let's look at the program. Here, let me close project, and then I will open a new project. So let me go to programming language chapter 8, and there's 2. Right here, we have 2 namespace. Okay, right now I'm using second. Let me check the second namespace. I mean, build it. And then let's run it. So as you can see, the result is 2 as second namespace. Now let me remove this and set it to first. Something wrong with my keyboard. My keyboard is very unstable today. Let me use mouse operation. Copy. And let me do paste. Okay. Then I hit build again. And then I hit run. So now it becomes 1. So right here, if I, okay, then let's go back. Let's go back to this file. That's namespace 2 project. Now, next one, we have namespace 3 project. In namespace 3 project, we actually we will have a declaration for namespace first, and then we directly use that namespace in the global position. So everything here will be namespace first. That will be empowered. So let's close this project again. And let me open. So that's namespace 3. So right here, let me build it again and run. It's just to show you the program itself is very simple, just for you to understand what namespace is. And then the next one, different varieties for using namespace. So right here, we have 2 numbers that's in my namespace. So you can put variable, and the 2 variable you can assign with different value. But to access it, you can use this namespace and double column. Let's bring back to the previous one. This one you use first, because you use the namespace first. So right here, this I is this I. You don't need to have this. You don't need to actually have the namespace description and double column. So let's look at the example. Now this one is actually having this one. So now if I have namespace 3, I use, sorry, I'm in Chinese mode. So right here, if I hit / comment it out, and I rebuild it. Okay, whatever it is. You cannot see the I declaration, right? So that's the problem. Let me actually do this, and it passes, you can run, right? And if I do this, say first, and double column. This one is use this namespace and this, build it. Okay, it still can run, right? So that actually is the use of the namespace name. If you have the using and you specify that, actually you don't need to have that prefix part. It will still work. Now let's bring up NS4. Bring up this NS4. So NS4 right here, we have two namespace name, right? And right here we use the to create a object, but this is very wordy. So let's do this. Okay, it's up to date, wrong. It can wrong, right? Now, but if we use, say, let me actually comment this out. If I comment this out and actually I copy them. I copy them and then I uncomment them. And then here I actually delete all of these. And then now I compile. Okay, you see the error. And then if I use, say, I use using namespace and then my namespace. Okay, and run, it's get out. So that's how you use the namespace. When you use it, you can actually make sure this domain is actually using this namespace definition. But let me roll it back. Let me keep it here. And then comment these two lines, and then comment out this line for future use. Okay. And I build it once. Now, let me go back to the slides. So that's how this 4 is using. I give you the scope resolution. And the last one is the NS5. Excuse me. And this one actually has the MySpace 1 and MySpace 2. And each one has the N1, N2, num1, num2 declaration. So that two namespaces sharing the same file, and I actually set up this. So now let's do this. Let's close this file. Let's save all file and close this project. And I open the NS5 project. So right here, actually, I should do the following thing. Enter. Okay, so I have two namespace, one my namespace 1, one my namespace 2. And with this, actually, if I compile, I'm sorry, this is using the old build. I'm sorry, I should build it first. And then again, this show the error. So what I should do is actually right here, I should use using namespace my namespace 1. Okay, and then let me compile and then run. So I get the result. That's 8050, right? So if I do this, let me actually, sorry. Let me do this. If I copy this one, copy, and let me paste. Okay, and then I change this to namespace. I'm sorry, it's into 2, namespace 2, and instead of 80, 50. Let me put minus 80 and minus 50 for the namespace 2, right? And since this num1 and num2 has no prefix, so in this case, let me compile. Actually, let me save it. And I need to quit this first. And then I compile. Nothing wrong. And I print it. Now it's 80, 50 for namespace 1. Now, if I change it to namespace 2, in namespace 2, right here, I set the num1 and num2 in both namespace to have positive and negative value, right? And right here, I'm using namespace 2 and see how this num1 and num2 respond. So this time it's 80, minus 80, and minus 50. So this show you by using namespace, I can switch the domain that you want to have, the scope that you want to have by using different namespace. And those namespace specifier will determine which num1 and num2 will be defined when they do the compilation. Okay, let's go back. This is the last slide for this chapter. And I'm sorry that this whole quarter or semester for this programming language 1, we have been rushing from chapter 1 to chapter 8. In this first 5 weeks, we are almost on a 2 chapter a week pace. But I believe that in the coming 3 weeks, we will drop to 1 chapter a week format. And also, I will save the time for you to develop your term project. And I'm sorry that this is very rushed, in a very hurry, because I don't actually think that 8 weeks is enough to teach enough material for programming language. And I'm trying my best to include all of the material in 1 quarter, and make sure that if you are not able to finish everything, try to download everything that you can download, and also make the link that you can link to your website, your own bookmarks. So in the future, you can, if you finish this course, you can still come back to do referencing on the material that's available on this course. Hope you enjoy this course. And the coming 3 weeks, we will be focused on chapter 9 for procedure or subroutine, 10 for object-oriented programming, 13 on concurrent programming. It's all related into the structural programming, object-oriented programming, and the concurrent programming. And they will be talking about the control flow of a program. And I believe that will bring you to another topic related to interesting feature of programming languages. And hope you enjoyed it. And if you have any questions, just let me know. So let's conclude this chapter. Thank you.